On May 16, 1940, William Cudson sat in his office at General Motors headquarters in Detroit, reviewing a telegram from Washington. The message shocked him. President Roosevelt had just addressed Congress with a proposal that seemed unimaginable. America needed the capability to produce 50,000 military aircraft per year. Cudson was not an ordinary factory manager. He was the president of General Motors Corporation, the largest industrial company on Earth. He oversaw more than 200 plants and 350,000 employees. His annual salary exceeded $300,000, more than any other corporate executive in the country. He had spent 37 years building his expertise in manufacturing. He knew automobiles. He knew factories. He knew production systems. He grasped what Roosevelt was truly requesting. The president wanted American industry to mobilize for war production on a scale never attempted before. In 1939, the entire United States had produced fewer than 3,000 military aircraft. The nation possessed 1,700 planes total in the Army Air Corps. Most of them were outdated. Now Roosevelt demanded a production capacity of 50,000 planes annually. That exceeded the total number of aircraft built in America since the Wright brothers flew at Kitty Hawk in 1903. The implications were immense. If America truly needed that many aircraft, war was imminent. And when it came, Cudson knew his world would transform entirely. Within 2 weeks, Roosevelt would summon him personally to leave General Motors and come to Washington to organize the nation's industrial mobilization. Cudson would agree. It was May of 1940. France was crumbling. Belgium had fallen. The Netherlands had been overrun. Hitler's armies were advancing toward Paris and the English Channel. Britain stood alone, and Roosevelt was calling on American industry to build an air force larger than anything the world had ever seen. The problem was that few believed it could be accomplished, especially not the Germans. In Berlin, Adolf Hitler received Roosevelt's speech with what his advisors described as amused skepticism. The Führer's intelligence officers prepared an assessment of American industrial capacity. Their conclusion was unmistakable. America could not build 50,000 aircraft per year. The proclamation was propaganda meant to intimidate Germany and boost Allied morale. The analysis appeared rational. American aircraft production in 1939 had totaled fewer than 3,000 planes. Even at maximum effort, German analysts projected America might reach 10,000 aircraft annually by 1942. 50,000 planes was pure fantasy. The German Air Ministry possessed detailed knowledge of American factories. They knew Boeing, Douglas, Lockheed, and Consolidated. They understood these companies produced aircraft one at a time, relying on hand-fitting methods. Skilled artisans assembled each plane individually. There were no mass production lines for aircraft. Automobiles could be mass-manufactured. Aircraft could not. The technical specifications were too demanding, tolerances too exacting, and materials too specialized. One German intelligence report from June 1940 concluded that Roosevelt's speech was a bluff intended to deter German aggression. The report stated American industry lacked the machine tools, the skilled workers, the engineering capacity, and the raw materials to produce more than 15,000 aircraft per year under optimal conditions. The analysts were certain. America was not a military power. It was a nation of farmers and car makers who had never mobilized for industrial warfare. The United States had no modern army, no strategic air force, no experience with large-scale weapons production. German planners estimated it would take America at least 4 years to build the infrastructure needed for serious military production. By that time, Germany would control Europe, and American intervention would be irrelevant. Hermann Göring, commander of the Luftwaffe, reinforced Hitler's confidence. Göring told the Führer that Americans could build excellent refrigerators and automobiles, but complex military aircraft required German engineering precision. The Americans lacked the industrial culture and technical sophistication for weapons manufacturing at scale. Hitler believed him. This belief would prove to be one of the most catastrophic intelligence failures in military history. But there was one man in America who thought Roosevelt's number might actually be possible. His name was Charles Sorensen, and he worked at Ford Motor Company as vice president of production. Sorensen was 60 years old in 1940. He was born in Denmark, came to America as a child, and spent his entire adult life at Ford. He'd helped Henry Ford create the moving assembly line in 1913 at the Highland Park plant. That assembly line revolutionized manufacturing. Before Ford, cars were built like aircraft, one at a time, by teams of craftsmen. Ford's assembly line broke car production into sequential tasks performed by workers stationed along a moving conveyor. Each worker did one job repeatedly as the chassis moved past. The result was mass production at unprecedented scale. By 1927, Ford had built 15 million Model T automobiles using assembly line methods. Sorensen understood something the German analysts did not. The principles of mass production could apply to anything, including aircraft. The Germans were right that American aircraft companies built planes like craftsmen, but they were wrong to assume that method was the only way. Sorensen had witnessed the transformation of automobile manufacturing from craft production to industrial scale. He believed the same transformation was possible for aircraft. The question was whether anyone would let him try. In January 1941, Sorensen traveled to San Diego to visit Consolidated Aircraft, the company that designed the B-24 Liberator bomber. Edsel Ford, Henry's son and the company president, went with him. They toured the Consolidated factory. Sorensen watched workers assembling B-24 bombers on the factory floor. There were no blueprints, just sketches and templates. Workers measured parts by hand, fit them together manually, drilled custom holes, filed edges until components matched. Each bomber was slightly different because every part was custom fitted. The factory could produce one B-24 per day maybe. Consolidated management was proud of this output. They thought one bomber per day was excellent production. Sorensen thought it was insane. He saw what they could not see. The B-24 had 200,000 individual parts, but those parts could be standardized. They could be manufactured on precision machines. They could be assembled in sequence on a moving line. The technology already existed. Ford used it every day to build cars. A Ford V8 engine had over 200 precision machined parts that fit together with tolerances measured in thousandths of an inch. The B-24 was larger and more complex, but not fundamentally different. It was an engineering challenge, not an impossibility. That night, Sorensen stayed up in his hotel room at the Coronado, thinking about what he had seen. He knew how to mass-reduce complicated machines. A car engine had thousands of parts that had to fit precisely. A B-24 had more parts, but the principle was the same. Break the product into sub-assemblies. Standardize every component. Create tooling that produces identical parts. Build the sub-assemblies in parallel. Bring them together on a moving assembly line. Let the product move, not the workers. By 4 around in the morning, Sorensen had sketched the entire plan on hotel stationery and the backs of placemats. He showed it to Edsel Ford at breakfast. The plan called for a factory that could produce one B-24 bomber every single hour. Consolidated Chief Executive Reuben Fleet looked at Sorensen's sketches and laughed. He said it could not be done. Aircraft were not cars. The B-24 weighed 35 tons. It had a wingspan of 110 ft. Its engines alone weighed over 1,000 lb each. The idea of mass-reducing bombers on an assembly line was absurd. Sorensen asked Fleet a simple question. If Ford agrees to build B-24s, will you provide the technical specifications and engineering support? Fleet said yes, assuming Ford would build sub-assemblies for final assembly at Consolidated plant. Sorensen said no. Ford would build complete aircraft or nothing. Either Ford could run the entire production process using assembly line methods, or Ford was not interested. Fleet thought Sorensen was bluffing. He agreed to the terms. Certain Ford would fail. Sorensen went back to Michigan and convinced Henry Ford to build a factory specifically designed to mass-reduce bombers. The plant would be unlike anything that had ever existed. The factory that became known as Willow Run. Construction began April 18, 1941 at a site 35 miles west of Detroit, near Ypsilanti, Michigan. The architect was Albert Kahn, who had designed Ford's other factories, including the massive River Rouge complex. Sorensen gave Kahn the specifications. The building needed to be large enough to house an entire bomber assembly line under one roof. It needed conveyor systems, machine tools, storage for thousands of parts, and space for tens of thousands of workers. KHN designed an L-shaped structure covering 3.5 million square ft of floor space. It was the largest factory building in the world by a significant margin. No structure this large had ever been enclosed under a single roof. The assembly line would be 1 mile long with a 90-degree turn halfway through. The plant would include its own power station, its own fire department, and its own hospital. Adjacent to the factory, Ford built Willow Run Airport with 6 runways so bombers could be test-flown immediately after leaving the assembly line. The airport included 3 hangars, the largest capable of housing 20 B-24s simultaneously. It also included a control tower, a cafe, and a hotel for test pilots. The total cost was $47 million, equivalent to over $800 million today. The construction itself was a massive undertaking. 300 men with saws, axes, and bulldozers cleared 100 acres of woodland. The site had been Camp Willow Run, a four-downed property used for youth camping programs. The land was adjacent to Willow Run Creek, which gave the facility its name. A steam-powered sawmill from Henry Ford's Greenfield Village Museum converted felled trees into 400,000 board feet of lumber used in temporary construction structures. The building materials included 44,000 tons of structural steel, more steel than was used to build the Empire State Building. Over 1 million square ft of glass provided natural lighting throughout the facility. The concrete foundation required enough material to pave a highway from Detroit to Chicago. The roof alone covered 78 acres. Workers installed 500 m of electrical wiring and 93 mi of conveyor systems. The plant had its own water treatment facility and sewage system capable of serving a city of 50,000 people. Ford spent an additional $20 million on tooling and equipment. The company installed 7,500 machine tools, including massive presses capable of stamping entire wing sections. Some machines weighed over 100 tons and required special foundations. The scale of the operation was unprecedented. Everything about Willow Run was designed for one purpose: mass-reducing heavy bombers at a rate no one believed was possible. German intelligence learned about Willow Run in mid-1941 through various sources, including trade publications and American newspapers, which openly reported on the massive factory construction. Their assessment remained unchanged. The factory might be large, but America still lacked the skilled workers, the precision tooling, and the organizational capability to mass-produce aircraft. The German Air Ministry estimated Willow Run would produce maybe 200 bombers per year at best, probably fewer. The factory was formally dedicated on October 22, 1941 in a ceremony attended by Major Jimmy Doolittle of the United States Army Air Forces, who would later lead the famous raid on Tokyo. Production began immediately. Parts manufacturing started that month. The first month, Willow Run produced 0 completed aircraft. In November, 0. In December, 0. In January 1942, 0. By February 1942, 9 months after construction began, Willow Run had produced exactly 0 B-24 bombers. The plant was running, workers were present, machinery was operating, but no finished aircraft emerged. The problems were immense. American newspapers began calling the factory Will It Run instead of Willow Run. The name stuck and became a source of embarrassment for Ford. Congressional investigators visited and wrote critical reports questioning whether Ford's automotive expertise would translate to aircraft production. Senator Harry Truman, chairman of the Senate Special Committee to investigate the National Defense Program, toured the facility in April 1942 and questioned whether Ford could actually make the transition from automobiles to aircraft. Truman's committee was investigating waste and inefficiency in defense production. Willow Run looked like a prime example. The plant had cost tens of millions of dollars, but had not produced a single combat-ready bomber. The problem was, Ford had never built aircraft before. The company had produced the Ford Triotar transport plane in the 1920s, but that was small-scale production of a much simpler aircraft. The B-24 was orders of magnitude more complex. The workers did not know how to work with aluminum. Automotive workers were accustomed to steel, which was harder and more forgiving of rough handling. Aluminum required different techniques, different tools, different training. The tolerances for aircraft parts were much tighter than automotive. Standards. Aircraft components had to fit precisely because any gap, or misalignment, affected aerodynamics and structural integrity. Cars could tolerate minor variations. Aircraft could not. The tooling designed for stamping car parts damaged the softer aluminum used in aircraft, dies that worked perfectly for steel-crushed aluminum. Sorensen had to redesign and rebuild thousands of tools. The cost was enormous. Millions of dollars in tooling was scrapped and replaced. Design changes from the military came constantly, requiring retooling that stopped production. Engineering changes were ordered in the first year alone. Every change required modifications to tooling, jigs, fixtures, and assembly procedures. Some changes affected multiple sub-assemblies, creating cascading delays throughout the production system, and the B-24 was vastly more complex than a car. It had 200,000 parts compared to about 15,000 in an automobile. The logistics of managing that many components were staggering. Each part had to be manufactured, inspected, stored, tracked, and delivered to the assembly line at exactly the right time. A single missing part could stop production, but Sorensen kept pushing. He reorganized the workflow, retrained workers, redesigned tools, and broke the B-24 into 11 major assemblies and 69 sub-assemblies. Each sub-assembly was built separately on its own production line, then delivered in sequence to the final assembly line. The center wing assembly became the heart of the production system. All prefabricated structures were manufactured to precise specifications, so they would snap into place without custom fitting. A multiple-function machine completed 42 precision machining operations to 2/10,000 of an inch in 17 minutes. The transformation from craft production to mass production required retraining the entire workforce. Ford established an aircraft apprentice school at Willow Run that trained up to 8,000 students per week. Classes ran continuously. Workers learned riveting, sheet metal work, electrical systems, hydraulics, and quality control. The training was intense because aircraft work demanded higher standards than automotive production. A poor weld on a car frame was unacceptable. A poor weld on an aircraft could cause catastrophic failure in flight. Workers internalized this responsibility. They knew pilots' lives depended on their work. In September 1942, the first completed B-24 rolled out of Willow Run. It had taken 11 months from factory opening to first aircraft. The plane was christened the Spirit of Ypsilanti in a ceremony that drew local dignitaries and press. That bomber was not sent to combat. Neither were the next 55. They were used for training and transport because the quality was not good enough for combat operations. Army Air Force inspectors found defects, incomplete work, and deviations from specifications. Critics said the project was a disaster. A congressional committee report stated Ford had tried to build bombers like cars despite warnings from experienced aircraft manufacturers. The report was correct. But Sorensen did not stop. He used the rejected bombers as learning tools. Every defect was analyzed. Every problem became a training opportunity. Quality improved with each aircraft. In January 1943, Willow Run produced 31 bombers that met Army Air Forces standards. In February 59, in March 75, in April 104, in May 130, production numbers kept rising month after month. Workers mastered their tasks. Processes improved through continuous refinement. Tools were upgraded as engineers identified and resolved problems. By June 1943, Willow Run was assembling 190 bombers per month, more than double Consolidated's original San Diego factory output, and the rate continued to climb. The breakthrough occurred when Ford successfully integrated all 11 major assemblies into a coordinated production system. Wings were fabricated on parallel lines. Fuselages progressed through their own assembly stages. Engines arrived from Pratt & Whitney and were prepared in a dedicated area. Gun turrets came from subcontractors and were tested before installation. Every component converged at the main assembly line in precise sequence. In April 1944, Willow Run produced 453 B-24 bombers in 468 working hours, more than one bomber per hour, exactly as Sorensen had predicted years earlier, when Reuben Fleet had laughed at his hotel sketches. The factory operated 24 hours a day in 3 shifts. On average, a new bomber was completed every 63 minutes. The final assembly line moved continuously at roughly 100 feet per hour. Workers installed engines, mounted wings, fitted gun turrets, connected hydraulic systems, and installed avionics. Each worker had a specific task and a strict time frame to complete it. The choreography was precise. At peak production, 42,000 people worked at Willow Run. The workforce was remarkably diverse for 1944 America. Most had never built anything more complex than an automobile. Women made up 65% of the workforce, many entering industrial jobs for the first time. African American workers accounted for roughly 10%, despite facing discrimination in hiring and housing. Workers ranged from 18 to their 60s, coming from farms, retail, and domestic work. Ford hired and trained them because many skilled industrial workers had been drafted. Transportation to the plant was a massive logistical challenge. Many workers traveled from Detroit on special buses. The trip took over an hour on often congested roads. Ford operated 165 private bus routes, with 35 more added through public transit. The federal government constructed a residential community next to Willow Run to house workers and families. Called Bomber City, it accommodated 14,000 people at its peak, with temporary housing, schools, shops, medical facilities, and recreational areas. The government also built the Willow Run Expressway, one of America's first limited-access highways, which opened in September 1942 and immediately alleviated traffic. Infrastructure normally taking decades to complete was finished in months due to wartime urgency. By the end of 1944, Willow Run alone had produced more aircraft than Japan's entire 1944 output. Japan's total that year was roughly 28,000 planes of all types, while Willow Run produced over 5,000 B-24s. Boeing's Seattle plant built B-17 Flying Fortresses using similar assembly line methods, employing 35,000 workers and producing 350 B-17s per month at peak output. Douglas Aircraft in Long Beach mass-produced C-47 transport planes, the military version of the DC-3, building over 10,000 during the war. North American Aviation manufactured 15,000 P-51 Mustang fighters in California and Texas, arguably the best fighter aircraft of World War II, with performance exceeding anything Germany or Japan deployed. Consolidated's Fort Worth and San Diego plants produced thousands of B-24s using Ford-inspired assembly methods. Lockheed built 10,000 P-38 Lightning fighters. Martin produced B-26 Marauders. Republic manufactured over 15,000 P-47 Thunderbolts. Grumman built 12,000 F-6F Hellcats, and Vought constructed F-4U Corsairs. Every major American aircraft manufacturer had adopted assembly line production. The transformation occurred in under 3 years. Small companies that once built dozens of planes annually were suddenly producing hundreds per month. The automotive industry contributed beyond Willow Run. General Motors produced over $10 billion in war materials, including aircraft engines, turrets, and complete planes. Chrysler built tanks and aircraft components. Nash Kelvinator manufactured propellers and engines. The entire industrial base had been mobilized for war. American aircraft production grew exponentially. 159,000 workers produced 19,830 planes in 1941. By 1942, 2 million workers built 47,836 aircraft. In 1943, production reached 85,898. And in 1944, factories delivered 96,118 military aircraft, nearly double Roosevelt's original 50,000 per year goal. Aircraft continually improved. The B-17 evolved through versions AG with better armament, engines, range, and bomb loads. The B-24 underwent more than a dozen variant upgrades. The P-51 Mustang, introduced in 1943, had the range to escort bombers to Berlin and back, drastically reducing losses and changing the strategic bombing campaign. From 1940–1945, the U.S. produced over 300,000 military aircraft, including trainers, transports, fighters, bombers, and reconnaissance planes, more than Britain, Germany, Japan, Italy, and the Soviet Union combined. Britain built 130,000, Germany 120,000, the Soviet Union over 150,000, Japan 76,000, and Italy roughly 11,000 before switching sides in 1943. Total Axis production was approximately 207,000 aircraft. Total Allied production was over 600,000, with America contributing 300,000 of that total. The Germans noticed in early 1943, Luftwaffe intelligence received reports about American bomber formations over Germany. The numbers seemed wrong, too many aircraft. American bombers were appearing in formations of 300, 400, even 500 aircraft at once. German fighter pilots reported encountering endless waves of B-17 and B-24 bombers escorted by swarms of P-47 and P-51 fighters. When German fighters shot down American bombers, more appeared the next day and the day after. The Americans seemed to have an unlimited supply of aircraft. Luftwaffe Commander Hermann Göring initially dismissed the reports as exaggeration. Fighter pilots overestimated enemy numbers during combat. That was normal, but the reports kept coming. By mid-1943, it was clear the Americans were deploying bomber forces on a scale Germany had never anticipated. The 8th Air Force, operating from England, was conducting daylight bombing raids, with formations that sometimes exceeded 1,000 aircraft when fighters were included. The numbers were staggering. On a single mission in October 1943, the 8th Air Force dispatched 291 B-17 bombers to attack Schwein ball-bearing factories. Despite losing 60 bombers, the Americans returned 2 days later with another massive formation. This was industrial warfare on a scale Germany could not match. Every downed American bomber was replaced within a week. Every lost crew was replaced within a month. The replacement pipeline was so efficient that American bomber units maintained constant operational strength despite heavy losses. Albert Speer, Hitler's Minister of Armaments and War Production, reviewed German intelligence assessments of American industrial output. The numbers shocked him. American aircraft production in 1943 was over 3 times German production. American tank production was double German output. American shipbuilding was producing 1 cargo ship every day. Speer realized Germany had fundamentally misunderstood American industrial capacity. In his post-war memoir, Inside the Third Reich, Speer reflected on how German leadership had dismissed accurate intelligence about American manufacturing capability. He wrote about meetings where Hitler refused to believe reports from German observers in America. The Führer insisted American production claims were propaganda and that German quality would overcome American quantity. Speer knew by 1943 that this belief was catastrophically wrong. Germany was producing excellent weapons, but not enough of them. America was producing good weapons in overwhelming numbers. In industrial warfare, overwhelming numbers mattered more than marginal quality advantages. Speer calculated that by 1944, American industry was producing twice the total war output of all Axis powers combined. Germany controlled the industrial resources of most of Europe, utilized millions of forced laborers, and ran factories 24 hours per day. Still, Germany could not match American production. German fighter pilot Adolf Galland commanded Luftwaffe fighter forces from November 1941 to January 1945. He witnessed the ascendancy of American air power firsthand. In 1942, Galland's fighters dominated the skies over Europe. The Luftwaffe had superior aircraft, better training, and more combat experience than American pilots. German fighters shot down American bombers at unsustainable rates, but the Americans kept coming. By mid-1943, the situation had reversed. American fighters appeared in overwhelming numbers. Even when German pilots had tactical advantages, they were outnumbered 5-1, sometimes 10-1. Galland's pilots could shoot down American fighters, but reinforcements arrived the next day. The Americans seemed indifferent to losses. They had such industrial abundance that attrition was affordable. One German pilot described it as trying to stop an avalanche. You could destroy individual bombers or fighters, but the mass kept coming continuously. Galland reported to Hitler in late 1944 that German fighter forces were being overwhelmed not by superior tactics or aircraft, but by sheer production capacity. The Americans were building more planes than Germany could destroy. Galland requested permission to withdraw fighters from the Eastern Front to defend German cities. Hitler refused. He still believed Germany could prevail through technology and fighting spirit. Galland knew better. The war had become a contest of industrial output, and Germany was losing badly. At age 30 in 1942, Galland had become the youngest general in the German armed forces. By 1945, he was flying missions with experimental jet fighters because conventional piston-engine aircraft could not match the flood of American planes in European skies. In December 1944, Germany launched the Ardennes Offensive, known as the Battle of the Bulge. The attack achieved initial surprise and some gains, but within 3 days, American air power arrived in overwhelming force. Weather had initially grounded Allied aircraft, chosen deliberately by German planners. On December 23, skies cleared, revealing the full scope of American air production might. Hundreds of P-47 Thunderbolts and P-38 Lightning fighters struck German columns. B-26 Marauder medium bombers hit supply lines. 8th Air Force heavy bombers diverted from strategic targets to destroy communications centers and rail yards. From December 23 to January 16, Allied air forces flew over 74,000 sorties, dropping 111,000 tons of bombs. They destroyed 11,378 transport vehicles, 161 tanks and armored vehicles, 57 locomotives, 6,266 rail cars, and 472 gun positions. German troops had never encountered such concentrated air power. The sky was dominated by American aircraft. Anti-aircraft fire destroyed some, but more immediately replaced them. The Germans had no effective counter. Research later concluded the Battle of the Bulge was the first time air power decisively halted a counteroffensive. The Ardennes advance slowed December 24 and ceased December 25, perfectly timed with Allied air activity. The offensive failed because American air power destroyed German supply columns and trapped forces in a lethal zone. That air power existed due to factories like Willow Run. By January 1945, the Luftwaffe ceased to be an effective force. Fuel shortages, pilot attrition, and overwhelming numerical disadvantage made German aircraft almost irrelevant. American bombers flew daylight missions with minimal losses. Fighter escorts hunted targets across German skies. Factories, railways, oil refineries, and transport networks were systematically destroyed. The strategic bombing campaign was sustained because American industry replaced losses quickly. Each B-17 or B-24 shot down was replaced within days. Pilot losses were replaced by graduates of flight schools. Germany could not match this rate. By the end of the war in August 1945, U.S. aircraft production totaled 300,000 military planes, including 37,000 B-24s. Willow Run alone produced 8,685 B-24s, including 1,893 knockdown kits shipped to other plants. The final B-24 left Willow Run on June 28, 1945. Charles Sorensen had left Ford by March 13, 1944, amid a power struggle with Henry Ford, just as Willow Run hit peak output. Sorensen went to Willys Overland and never returned. He received no official recognition, though his work was instrumental. William Knudsen, who had doubted Roosevelt's targets in 1940, became Commissioner of Industrial Production and coordinated mobilization across the U.S. economy. In 1942, he was commissioned a lieutenant general without prior military service, working until 1945 to organize tanks, trucks, weapons, ammunition, and aircraft. He later asserted that victory was decided in factories, not battlefields. The side producing the most weapons, aircraft, and tanks would win. Knudsen was correct. Roosevelt's arsenal of democracy was literal. By 1944, the U.S. produced 64% of all Allied war material, exceeding all other nations combined, including its allies. Hitler witnessed the consequences of underestimating American industrial capacity. By April 1945, Soviet armies fought in Berlin, while American and British forces controlled Western Germany. German cities lay in ruins from strategic bombing. The Third Reich collapsed. In his final days, Hitler blamed generals, traitors, and advisors, but not the industrial juggernaut he had dismissed in 1940. Those advisors had told Hitler that Roosevelt's 50,000 aircraft per year was impossible. They had assured him American industry could never mobilize for total war. They had convinced him Germany would win before America could build enough weapons to matter. They were wrong about everything. The 50,000 aircraft per year that seemed impossible in May 1940 had been exceeded by 1944. American factories built 96,000 aircraft that year alone. The total over 5 years reached 300,000. The Germans had colluded propaganda. America built the planes anyway, and those planes destroyed the Third Reich from the air. Albert Speer survived the war and spent 20 years in Spandau prison as a convicted war criminal. In his memoir written in prison, Speer reflected on Germany's strategic mistakes. He wrote that the greatest error was underestimating American industrial power. German leaders had looked at America's small peacetime military and concluded America was weak. They had ignored America's massive industrial infrastructure, its engineering capability, its tradition of mass production innovation, and its capacity for rapid mobilization. Speer calculated that by 1944, a single American factory like Willow Run was producing more aircraft per month than entire German industrial regions. He wrote that Hitler's decision to declare war on America in December 1941 was the moment Germany lost World War II, not because of American military power. At that moment, America barely had an army, but because declaring war on America guaranteed that American industrial capacity would be turned fully toward destroying Germany, and once that industrial power was mobilized, Germany had no counter. Speer stated that if German intelligence had accurately assessed American industrial potential in 1940, Hitler might have made different strategic choices. But German analysts looked at American aircraft production in 1939, saw fewer than 3,000 planes, and assumed that represented America's maximum capability. They failed to understand that American industry had not yet tried to build aircraft at scale. The production in peacetime was constrained by limited military budgets and small orders, not by industrial capability. Once American industry applied mass production techniques developed for automobiles, shipbuilding, and machinery to aircraft manufacturing, the production numbers increased 32-fold in 4 years. No German planner had thought that was possible. The final count of American aircraft production during World War II stands at 300,000. Military aircraft from 1940 to 1945. That number is difficult to comprehend. Because of its scale, 300,000 aircraft. If you laid them wingtip to wingtip, they would stretch from New York to Los Angeles and back twice. If you stacked them one on top of another, the stack would reach beyond the edge of space. The combined weight of all aircraft produced was over 6 billion pounds of aluminum, steel, rubber, and electronics. The production required 150 million board feet of lumber for crating and shipping. It consumed 2 billion rivets. It required enough electrical wiring to circle the Earth 40 times. The manufacturing employed over 2 million workers at peak production in 1943. Those workers operated in factories totaling over 100 million square ft of floor space. The factories used more electricity than the entire city of Detroit. They consumed raw materials shipped from every state and multiple countries. American industry built the supply chains, trained the workers, designed the tools, and solved the production problems in less than 4 years. From Roosevelt's speech in May 1940 to peak production in 1944 was exactly 4 years. In that time, American aircraft production increased from fewer than 3,000 planes per year to 96,018 planes in 1944 alone, a 32-fold increase. No other industrial mobilization in history matched that scale or speed. When historians analyze how the Allies won World War II, they focus on battles: D-Day, Midway, Stalingrad, the Battle of Britain. But those battles were won with equipment built in factories. The B-24 bombers that struck German industry were built at Willow Run. The P-51 Mustang fighters that escorted those bombers were built at North American Aviation, plants in California and Texas, the C-47 transport. Planes that dropped paratroopers at Normandy were built by Douglas in Long Beach. The Liberty ships that carried supplies across the Atlantic were constructed in shipyards using assembly line methods, adapted from aircraft production. Every weapon, vehicle, and bullet came from American factories. The soldiers, sailors, and airmen who used those weapons were brave. The generals who planned operations were skilled. But without the industrial base providing equipment in overwhelming quantities, tactics and courage alone would not have sufficed. Germany had brave soldiers and experienced generals. Japan had highly trained pilots and seasoned commanders. Both lost because they could not match Allied industrial output. American industry made Allied victory inevitable. Once the factories reached full capacity, the Axis powers were fighting a war they could not win. The outcome became a matter of time. The story of how America built 300,000 aircraft in 4 years is not just military history. It is a story about industrial capacity, engineering, innovation, organizational skill, and national mobilization. It is about Charles Sorensen staying up all night in a San Diego hotel room sketching an assembly line for bombers on placemats because he believed mass production could work. It is about 42,000 workers at Willow Run, most of them women, many with no prior manufacturing experience, building one bomber per hour across 3 shifts every day. It is about Albert Kahn designing a factory larger than anything previously built to house a mile-long assembly line. It is about William Cudson coordinating industrial mobilization across thousands of factories in 48 states. It is about Roosevelt setting targets that seemed impossible, and American industry meeting them. It is about German intelligence analysts examining American production numbers in 1939 and concluding that Roosevelt's speech was propaganda. Those analysts made a fatal error. They assumed American peacetime production represented maximum capacity. They did not realize that American industry had never tried to build aircraft at full scale. They did not anticipate that assembly line mass production methods could succeed for aircraft. They could not imagine factories like Willow Run. By the time German leaders recognized their mistake, it was too late. The American industrial machine was fully mobilized, producing weapons faster than Germany could destroy them. That was the real lesson of World War II. Industrial capacity matters more than tactics. Production wins wars. American industry outproduced the entire world combined. 300,000 aircraft in just 4 years, from fewer than 3,000 per year in 1939 to over 96,000 in 1944. The Germans called it propaganda. America built them anyway. If you found this story compelling, please like this video. It helps us share more forgotten histories from World War II. Subscribe to stay connected with these untold stories, and leave a comment telling us where you are watching from. Our community spans the globe, and every viewer helps keep these histories alive. Thank you for watching. Histories alive. Thank you for watching.